Hello, everyone. Unfortunately, I will not be with you for class today, but I will instead make this video lecture to keep everyone caught up and try my best to get better so that I can come back to class and we can have a good time. So that is the video lecture for 1.1 part 1. 2 parts to this chapter, and we will just go over the first part this week. Now, this part 1, understanding points, lines, and planes, it is fundamentals. It is talking about postulates. If you have not finished the vocab yet, I would recommend you write those down because we'll be using some of those words today. So we should be able to graph these inequalities. It's something we've done in Algebra 1. And kind of the completed answer here for you, we have this ray at greater than or equal to 3, so we use this closed point, and we shoot her off in the direction anything greater than or equal than 3. And then we have x between 2 and 6, and those are both equal to or less than or equal to, so 2 is less than x is anywhere in here, which x is then less than or equal to 6. So it's going to be everything in between. And x is less than 1 or x is greater than 0. Well, we actually have some kind of overlap going on here, which means we're essentially left with a line. However, we're going to go off in both directions, and you should have something like that. If you have any questions, feel free to email me. Let's continue on. Perfect. All right, so our objectives for the day are to identify, name, and draw points, lines, segments, rays, and planes. Apply basic facts about points, lines, and planes. We want to be able to do that by the end of this lesson. These are the vocab words we'll be using for this lesson. All of them on here will be words that you should have written down. So point, line, collinear, segment, ray, all words we've written down in either our iPads or the back of our notebooks. The most basic figures in geometry are undefined terms, which cannot be defined by using other figures. The undefined terms, point, line, and plane, are the building blocks of geometry. Now, we call a line and a plane undefined because it goes on forever. So a line, I cannot define a line because I cannot assign a measurement to that line, right? Now, if I have something like a line segment, this is a definable term because I can say this line segment is 6 meters long, right? But I cannot define this line. This line goes on forever, and therefore I cannot say it is 6 meters long or it's 5 meters long. I cannot say that. Let's continue. All right, these are things we should be familiar with, again, with the vocab that we've already done. I would recommend that if you don't know how to write these out yet, that you either write this part and this part down. Again, this is how I expect you to write a line, XY or YX. And plane R or plane ABC. I need 3 points to make a plane. I need at least 3 points to create a plane. Some people ask me, if I have 4 points, should I write down all 4 points? Probably not. Probably just write down the 3 points. So plane ABC, if there was a 4th point here called D, I would say either put ACD or ABC or BCD. Plane, of course, but maybe not ABCD. All right. Points that lie in the same line are collinear. That's the definition of collinear. Something like K, L, and M are collinear. K, L, and N are non-collinear. That's what we say about points that are non-collinear, essentially, right? Points that do not lie on the same line. So in this case, just by adding something like N, I am turning K and L, which are collinear, to non-collinear, right? I am saying that K and L may be collinear, but as soon as I add N in here, these 3 points are non-collinear because N does not lie on that line, right? Points that lie on the same plane are coplanar, and we can call points that do not lie on the same plane non-coplanar. And I'm going to move a little fast, so if you ever need to pause the video, please feel free to do that. All right, so here I've kind of given you the second one. I think it's a little difficult to kind of see this. So AE, BE, and CE, those are all lines, right? AE, BE, CE. Kind of draw them out as best as I can. So, and for coplanar points, well, we can kind of see this plane at the bottom, right? So for coplanar points would be A, D, C, and B. Those are lying on that plane, that rectangle on the bottom. And although that plane should extend forever in all directions, these 4 points all lie on that plane, that coplanar. There, they are coplanar. So just to kind of show you again, bam, A, B, C, and D are on that plane. Therefore, they are coplanar points. All right, so you're going to have to kind of gaze into this one. It's hard to see these lines. Use the diagram to name 2 planes. Well, like I said before, I only need 3 points to define planes. So in the case of the top one, all I need are those 3 points, plane A, B, C, right? In the case of the bottom one, I can call it plane R, or I can call it plane NML, and a plethora, a lot of other ones. So I could say plane LKN, I could say plane KNM, I could say plane LMN. You know, I could go in many different directions, as long as you have 3 points. Like I said there, plane R and plane ABC. So again, as we look at the top here of these segments, well, we already know what a segment is, and if you need to write these down for vocab, please feel free to do so. I specifically want you to put the 2 dots on here to show that it's a segment, okay? As for endpoints, those are points, we can call them C and D. A ray, again, I would like to have that dot on there, that endpoint, so I know that you're talking about the endpoint at being at R and going to S forever, going out for infinity to S, through S. Opposite rays are 2 rays, and this isn't necessarily one of our vocab words, but it is nice to know. We have something like EF and EG. We call these opposite rays because they have a common endpoint and they actually form a line, right? So I could say that this is FG, the line, right? Or I could say EF as a ray and EG as a ray, and I wouldn't know the difference, honestly. Opposite rays, again, are just 2 rays that go in opposite directions. They technically form a line, and they also form 180 degrees. So as an angle measurement, which all lines do, right? All right, move on here. Like I said, if I'm going too fast, I recommend you pause the video to write these down. So if I wanted you to make an n segment with endpoints m and n, I would have you essentially make this line, right? This segment. How would I have you write it out? Well, I would do mn, and I would put those two endpoints on the line I put above it. And let's say I want opposite rays with common endpoint t. Well, I could just make these opposite rays with the common endpoint t. I could also include other points on here, like if I wanted to put a point here and call it r, put a point here and call it, let's say, s. That way I could start labeling my rays. I could say ray ts, the ray symbol where I need it to be, and ray t r. Right? T is supposed to be capitalized. So again, that endpoint being on T, extending out through R. Right, let's continue. Draw and label a ray with endpoint M that contains N. So I already have them on here for you, but this is a ray with endpoint M that contains N, right? So it just needs to have N somewhere in there. Obviously not the endpoint because M is our endpoint. If I wanted to write this out, certainly could, as mn with the ray on top. All right, let's keep moving. A postulate or axiom is a statement that is accepted as true without proof. Postulates are about points, lines, and planes help describe geometric properties. Actually, those very basic postulates that we go through will help us define not only the fundamentals of geometry, but anything later that we use for geometry. And having this area for us to build up and use these postulates is actually going to be really helpful. All right, so I would recommend you pause the video and you write these postulates down because they're really helpful to have. So through any 2 points, there's exactly one line. So I can make at 2 points, I could draw a line through it. That's what that's saying. Through any 3 non-collinear points, there's exactly one plane containing them, which means I can take any 3 points and I can make a plane out of it. All right. They do not have to be collinear. They do not have to be on a line, but the 3 points will technically be coplanar. And finally, if 2 points lie in a plane, then the plane containing those points lies in the plane. So if I have 2 points on this plane, the line that I draw has to also lie on the plane. I get a question sometimes that is asking me, well, how do I know it's lying on the plane? And that basically the short of it is if every point on this line lies on the plane, then it's lying on a plane. If I have an intersection, so if I have a different line, let's say I have a line intersecting this plane and it is kind of looking like that, is intersecting right here. This is not lying on the plane. This is intersecting the plane. That is something very different that we'll be getting into a little later. All right, name a line that passes through 2 points. Well, I could say something like XY, right? I could put it on a plane, and that way I know that this is not only collinear, X and Y are also coplanar. They're lying on the plane, right? Right, let's keep moving. Name a plane that contains 3 non-collinear points. So non-collinear are points that are not on the same line, right? So G and H are collinear, but as soon as I add F in there on plane R, as soon as I add F into the points that we have, these 3 points are non-collinear, all right? G and H are collinear. G, H, and F are non-collinear. All right. All right. So again, plane GHF. So we use systems of equations. I wouldn't necessarily recommend writing this whole paragraph down at the top, but I would recommend writing this little bit at the bottom about intersection. Intersection is the set of all points that two or more figures have in common. The next two postulates that we'll be discussing describe intersections involving lines and planes. So I would again suggest writing these down. You never know where they're going to pop up. So intersection of lines and planes 1-1-4 says if two lines intersect, then they intersect at exactly 1 point, which means if I take two lines like so, and I intersect them like so, they are going to intersect at exactly 1 point. All right, what about this? Well, planes for 1-1-5, two planes intersect, they intersect at exactly one line, right? So this is a line. You can kind of see where these two planes are intersecting. If you're having a harder time, I would recommend grabbing two pieces of paper and try to see if you can see that line, okay? See if you can't cut one of the pieces of paper and put it intersect the two. See if you can't find that line, all right? But this kind of shows you that if I intersect two planes together, I have a line right here, whoops, line right here, and a line right here, right? And these go on forever, planes go on forever, but unfortunately, I can't make a figure that goes on forever. It wouldn't make sense. So we have to cut these planes a little short. All right. So using a dashed line to show hidden parts, I demonstrated this earlier, but say I have a plane like so. Let's call this planar. And I have a line intersecting through the plane. Well, the front side is going to have that line, and I'm going to put that point of intersection on there. And then I'm going to make a dotted line because that dotted line tells me that this line, that is the back part of the line, okay? And once you have space to see the line again, then you can start drawing it out without the dotted line part. All right. So make sure you are making your figures correctly because they will really help you. This one's kind of already done for you. I would recommend maybe doing this yourself, but sketch two lines intersecting exactly 1 point. Well, that's just our postulate, right? Sketch a figure that shows a line that lies on a plane. Well, this line lies on the plane. Every point on this line is on the plane. So it is this line lies on the plane, right? All right, let's keep her jamming. Show you a figure where of two lines that intersect in 1 point on a plane, but only one of the lines lies on the plane. So something like this, I know that this line right here lies on the plane, right here. This line lies on the plane, and then I'm going to make another line that intersects with the plane and also intersects with the line. This line, the second line I drew out, does not lie on the plane. So did I figure this out? Let's see. Two lines intersect in 1 point. Two lines intersect at 1 point. That certainly, I've done that. But only one of the lines lies on the plane. Okay, so this line lies on the plane. This line does not. Only one line lies on the plane. Looks like I got it. All right, I can make two opposite rays at CB and CD. Those are opposite rays. The intersection of plane N and plane T is BD, right? Because when I intersect planes, the postulate tells me 1-1-5 tells me that when I intersect two planes, the intersection is a line, right? So otherwise, a point on BC, well, BC is the line. I could say that D is the point that lies on BC. I can actually just put D. I don't have to put that point next to it. I could also say that C and B are points that lie on BC, right? But other than that, yeah. And this one is actually referring to the ray BC. Otherwise, a plane containing E, D, and B, well, E's right here, D's right here, and B's right here, that would be plane T. All right. You need to pause the video, go ahead, otherwise I'm moving on. So D, plane T. All right. A line intersecting a plane at one point, I could draw that out pretty quick, right? A line intersecting a plane at one point, I would make my plane, maybe call it plane R again, and I would pick a point that my line intersects through, and then I would draw that line out. So again, it's not, this one is intersecting, it's not lying on that plane. It is simply, I'm jutting a line through a ray with endpoint P that passes through Q. So a ray with endpoint P. So I automatically know this is a ray with endpoint P that passes through Q, which means Q has to be somewhere on here. There we go. Ray with endpoint P passes through Q. All right. We're almost done. There, in case you wanted to get a better idea, those are basically the same thing I just drew up. All right, this is the start of part 2. We will not be doing part 2 until after NWEA testing. So I would recommend that you watch this video. People, B days, you will have to watch this video as part of your homework, and I will be delaying the turn-in for some of the other homework in the course. That way I have time to make these videos and basically allow people to have a little extra time to understand these concepts, because I know video is kind of hard to do. All right. Otherwise, thank you for watching and have a wonderful day.